Okay, so we're looking here at some solving equations. We do these by balancing, inverse operations, however you want to call it. So remember the algebra, the letter, okay, is a number in disguise, and you've got to get rid of that disguise and work out what the number is. Now, these numbers can be positive, negative, fractional. They don't have to be whole numbers. Okay, so here we go. So essentially, if you look here, 3x take away 1 makes 14. So therefore, what number take away 1 makes 14? I get rid of this negative 1. I'm going to add 1 to both sides. So I get 3x equals 15. 3 lots of something's 15. I'm going to divide both sides by 3. Remember, you have to divide both sides by 3. That's the balancing bit to keep both sides equal. And so you get x equals 5. There. Now, the second one looks a bit worse because it's got fraction in, but actually it's exactly the same thing. So what number add 2 makes 10, or take 2 away from both sides? Either is a good way to think about it. So I'm going to take away 2 from both sides, and I should get 8. Alright, so x over 4 equals 8. Now, something divided by 4 makes 8. Now, part of the reason I've done this particular example is because a very common mistake would be, well, that's 8 divided by 4. But it's not 8 divided by 4. It should be 8 times 4, because something divided by 4 makes 8. And so to get rid of divide by 4, okay, we need to multiply. The inverse of divide by 4 is multiply by 4. So I should end up with x equals 32 there. Now then, next one, go on to green. Need to expand the bracket first. You can do this without expanding the brackets, but I think it's good to get in the habit of expanding brackets, right, rather than do different methods for different types. Okay, so expand the bracket, I end up with 2x plus 6 equals 9. Okay, remember it's 2 times x, 2 times 3, or you could use my table. Okay, so 2 times x is 2x, 2 times 3 is 6. So there you go. Now I've got plus 6 here. I need to get rid of plus 6, so I take 6 away from both sides. 3. Alright, and then I've got 2 x's, I only want 1x. Divide by 2, and I end up with 1.5. Now, you can do that either as 3 over 2 or as 1.5. Doesn't really matter. I tend to use fractions only because they're generally more accurate, but it doesn't really matter. Now the last one is when we've got unknowns or variables or x's on both sides of the equals. Now the best way to do this is to look for which side's got more. So we're comparing the amount of x's. This side got 3 x's, this side's got 5 x's. So the right hand side has 2 more x's. So I'm going to remove 3 x's from both sides. Now if I remove 3 x's from both sides, I end up with this. Okay, so all I've done is remove 3 x's from both sides. Okay, so I've got rid of that, and I've taken 3x away from both sides there. Now 2x plus 6 equals minus 2. It doesn't matter the fact that it's that way round. I need to get rid of this this plus 6 by subtracting it. Okay, so I should end up with that. And then minus 8 equals 2x, divide by 2, minus 4 equals x. And the fact that it's that way round makes no difference really. Okay, well, it doesn't make any difference at all. Okay, because they're the same either way round. Alright, so it's all about inverse operations. Take care to do the same to both sides, and take a little bit of care when expanding brackets and things like that.